Welcome to your first video, geometry students, on the Monday after break. Sorry I couldn't be with you. I'm currently with my wife and my new kid. We had our child over the spring break, and so I'm spending some time with them. So I look forward to seeing you guys a week from today when I return. Know that we are going to have a Chapter 8 test on Wednesday. And so the last thing I want to do is start talking about 8.6. And the nice thing is that 8.6 is really nothing new. All it does is take everything that we've learned in the past of all of Chapter 8, and put it all together into one big pile to make sure that we know everything we need to know for the Wednesday's test. By now, I hope Mr. Bergstead has given you the quadrilateral properties review sheet, and really, all I want to do today is walk through that sheet and make sure we're all on the same page of all the different qualities and properties that each of these shapes hold. First thing I want to do before I actually get going on any one of those shapes, is show you this little flow chart. If you look at this thing from top to bottom, you can see that we've really been focusing on quadrilaterals, a four-sided polygon. And there's different types of quadrilaterals. On the far left, you see that there's a parallelogram. We talked about that when we walked around the room a couple weeks ago. We learned a bunch of different properties of a parallelogram. But then we also looked at the fact that, hey, a rectangle is actually a special case of a parallelogram, and so is a rhombus. Notice that a rectangle and a rhombus are side by side and not one within another. A rectangle is definitely not a rhombus, and a rhombus is not a rectangle, so they have their own unique properties. But the cool thing is that when we get a little bit deeper, you can see that the square actually flows from both a rectangle and a rhombus. And so a square holds the properties of a parallelogram because it's underneath that, but it also holds the properties of a rectangle and a rhombus. It's a special case of all three. If you move to the right, you can see we have a trapezoid and the kite, kind of the two odd ducks that we talk about quite a bit with quadrilaterals. We have a trapezoid, and underneath that we have an isosceles trapezoid. All it's saying there is an isosceles trapezoid is a trapezoid. It certainly has all the qualities of a trapezoid. The only thing unique about it is that it has the two legs that are congruent to each other. And then the kite is all kind of by itself because it has a bunch of unique characteristics that only a kite actually holds. So now take out a pencil and go ahead and follow along with me. I want to walk through this worksheet with you before we let you loose for the day. First things first, we have a quadrilateral. A quadrilateral, by definition, if I want to go ahead and fill in that space, a quadrilateral, I believe, is a four-sided polygon. In the most general sense of the word, okay, a quadrilateral is a four-sided polygon, and that's all I have. And another thing that I would probably at least know for the test is the fact that a quadrilateral has 360 total degrees on the inside. How do I know that? I know that by the definition, or the formula rather, that we learned in 8.1, 180 times n minus 2, where n is a number of sides. So I can do 180 times 4 minus 2, which is really 180 times 2, and then that should give me 360 total degrees. Notice that 180 times n minus 2 just doesn't work just for quadrilaterals. It works for any polygon, but that's certainly how I got the 360 total degrees on the inside. A quadrilateral doesn't really have a whole lot of properties because it's the most general term. As you move along here, we also have a kite. I think by definition, I believe a kite is a quadrilateral that has two pairs of consecutive, remember consecutive means ones that are right next to each other, consecutive congruent sides. So as you look at your picture there, it's already marked for you. Okay, you can see that it has two pairs of consecutive congruent sides. That's what the definition of what a kite is. But then it has additional properties. For example, if you drew in your diagonals, opposite corner to opposite corner, when I draw that, I think I also know that diagonals are perpendicular to each other. Similarly, the long diagonal, in this case from left to right, bisects a small one. So I can say, hey, that this little piece right here is congruent to this little piece right here. Additionally, I also know that the long diagonal cuts, or actually angle bisects the two angles that it touches. So I know down here in the far right, I know then that this has to be congruent to this because it cuts it in half. And similarly, I know that this right here has to be congruent to that because it cuts it in half. Finally, I'll use a different color. However you choose to do it is just fine. Okay, I know that the two angles that are touched by the small diagonal or the shorter diagonal, I know that they are congruent to each other. Okay, so if I know that they're congruent to each other, I know I have one pair of congruent angles inside of a kite. Now, at any point do you think I'm going too fast with a lot of these properties? every one of these properties are listed in one of those packets that we talked about. Okay, and this one happens to be in the 8.5 packet that we talked about before break. And so none of this is new. I'm just trying to put it all on one screen. The next one should be a parallelogram. And when you look at a parallelogram, okay, a parallelogram by definition is, again, a quadrilateral with both pairs of opposite sides parallel to each other. So again, I've already marked that on your paper. You can already see that you have two pairs of opposite sides that are parallel to each other. Okay, but then I have a bunch of actual definitions and actual properties that I know are congruent. First of all, I know that opposite angles are congruent. I know, so I can mark them both. I know that opposite sides are congruent, so I'm going to make that mark as well. I also know that if I know that the two on the side are supplementary to each other, we call them consecutive angles. So I know that these two right here sum to 180 degrees, these two together. Okay, and that's going to be the same thing over here, so we can kind of make one big arrow here if we want to. So the other one on this side, so these two on both sides, again, sum to 180 degrees. Okay, and I also know, okay, the other one that we can draw in there is the fact that if I go ahead and draw my diagonals in as best I can here, I know they cut each other in half. And so I know that this little piece right here should be congruent to this little piece right there. And similarly, this piece on this bottom left should be the same as the piece on the right. Okay, again, those are the kind of the big properties that we should know for a parallelogram. Moving on, you also have a rectangle. Okay, in a rectangle, we know specifically it's definitely a quadrilateral because it's four-sided. Okay, but we also know it actually holds all the properties of a parallelogram, so we can call it a parallelogram, but more specifically, it's a parallelogram with four right angles. So again, if you look at your piece of paper right there, you already have a rectangle that has four right angles posted in there. Okay, I know it has all the properties of parallelogram. So if it has the properties of parallelogram, I know opposite angles are congruent. Well, it's already marked. They're both 90. I know that consecutive angles are congruent. Well, I know that because they're both 90. 90 plus 90 equals 180. I know that opposite sides are congruent, so I can make those marks. Okay, and I also know that diagonals bisect each other. Okay, so again, if I draw my very poor looking diagonals in here, I know that this piece right here, if I can draw it correctly, should be congruent to that piece right there. And similarly, this little piece should be congruent to this little piece. Okay, but the only thing that's very different from a rectangle than it is a parallelogram, the one unique trait that I want you to put somewhere is the fact that diagonals are congruent. That's important. Okay, the diagonals are congruent, which means from top left to bottom right should be the same as bottom left to top right. Remember we talked about the TV and how you can say that 52-inch television goes from top left to bottom right, but they can also measure it from bottom left to top right. In both cases, it's going to be a 52-inch television as long as that television is rectangular. Okay, moving on. As you look at this one, we have a rhombus. A rhombus also is a parallelogram, so I'm going to make that note. It's definitely a parallelogram. So it has all the properties of a parallelogram, but more specifically, it's a parallelogram with four congruent sides, just like the picture shows here. So I have a parallelogram with four congruent sides. So again, it holds all the properties of a parallelogram. So first of all, I'm going to say that opposite angles are congruent. Got that. Got this one. That's good. I know consecutive angles are supplementary, so I know, for example, this angle and this angle should sum to 180 degrees. So if I look over here, I know that this one and this one are 180 degrees. I also know that diagonals bisect each other. I'll try and use a different color here. So if that's the case, I know that this little piece is congruent to this little piece. I know that piece is congruent to that piece. But then there's also two more properties for a rhombus here that we need to actually talk about. Okay, first of all, we know from what we explored last week that we know that diagonals are perpendicular. So you can see I put a right angle in here. You only need to really put one, but you can put as many as you want. All four of those angles are going to be 90 degrees. And I also know, okay, which is convenient, that these diagonals are angle bisectors. So I know, for example, in the bottom right in green here, I know that this little piece right here, okay, should be the same as this little piece down here. Okay, similarly, I know that this piece will be the same as this piece. And if I use one more color here, bottom right, 1, 2, 3, 4 should be the same as 1, 2, 3, 4. And up here, 1, 2, 3, 4 should be the same as 1, 2, 3, 4. Okay, this one probably has most of the properties. Okay, the picture gets pretty crazy pretty quickly. Okay, but it does definitely show a lot of different properties that you should know for a rhombus. Then you have the square. A square is the most unique and probably holds the most properties of them all. Okay, a square is, again, a parallelogram with 4 right angles, which is already showing on the picture, and 4 congruent, with 4 congruent sides. So if I were to make the marks, I already have the 4 congruent angles, and I already know that these are all going to be congruent to each other. So now I can just go ahead and add a bunch of different stuff on here. Okay, first of all, if I draw my diagonals in, I know a lot of different stuff. First of all, I know that the diagonals cut each other in half. Okay, so I'm going to make that mark. I know that diagonals are perpendicular to each other, so I know I'm going to make that mark. I also know that the diagonals are angle bisectors, so I'm going to make this mark is congruent to this, and similarly, this one is congruent to this. And the bottom right, same idea. They're all cutting each other in half. So I have all these angles that are congruent to each other. And because I know a parallelogram with 4 right angles, 4 congruent sides, we talked about that a square is also a rectangle. And we know a rectangle, okay, has diagonals. I'm not going to be able to put it on the picture, so I'm making a note to myself that diagonals are congruent to each other. So I know from top left to bottom right in blue should be the same as bottom left to top right. As a result of this, you should really know that this is a special case of a parallelogram, a rhombus, and a rectangle. Which implies that if I have any kind of property of a parallelogram, any kind of property of a rhombus, and any property of a rectangle, all should apply to a square. Finally, you have the one last odd duck. Okay, you have the trapezoid. When you look at the trapezoid, okay, there's only a couple things that we need to know. First of all, it's definitely a quadrilateral. Okay, in terms of the definition, it's a 4-sided figure, so it's definitely a quadrilateral. Okay, with only one pair of parallel sides. So you can see here, we call this the base. Remember the different definition. This is the base, and I'll call this the base up here, and I'll call this the leg, and I'll call these the legs. The non-parallel sides I'll call the legs. Okay, really the only characteristic that I really want you to remember, besides the fact that I have one pair of parallel sides, is the fact that I have this angle right here and this angle right here. These two angles, so I'll say this angle and this angle, better sum to 180 degrees. And the reason why I know that, folks, is if I go ahead and make a parallel line and a parallel line, and I go ahead and use that transversal through it, okay, I know that this angle right here and then this angle right here, okay, remember way back in the day we started talking about parallel lines and transversals. Those are consecutive interior angles, okay, especially since I know that these lines are parallel to each other. Okay, that way I know that those two angles must sum to 180. Same on this side. I know that this angle over here, it may not be the same, especially if it's not an isosceles, and this one may be even different yet. I know that this angle right here in the bottom right and this one up here, again, sum to 180 degrees for the same purpose. Finally, the last one is this. The last one is the isosceles trapezoid. The isosceles trapezoid, okay, should have a few more characteristics. First of all, it's a trapezoid. Okay, really the only thing that tells me is that the fact that I have one pair of parallel sides, and I know that the consecutive angles sum to 180 degrees. Okay, but if I have the isosceles trapezoid, the trapezoid, but with the legs congruent. So if I look at this over here, if this is my leg and this is my leg, notice a difference from the previous screen and then from the previous picture on your paper that you have now that those two legs and non-parallel sides are now congruent to each other. As a result of that, okay, we still know that this angle right here and this angle right here sum 280. And similarly, one on this side along with this side, again, make 180 degrees. But then there's a couple more things that we need to know. Okay, the one thing that we need to know is, I'm just going to bring up my notes here too so to make sure I don't forget them, is that if I draw my diagonals in from bottom left to top right and from top left down to bottom right, okay, I know that the diagonals, the diagonals are congruent to each other. And I also know that opposite angles are congruent. Okay, so if I have something like this, if I have an angle down here, and I'm making a mark with 1, that's bottom left, I know, okay, that the one up there are supplementary to each other. So I don't know if I said congruent, but the bottom left and top right, opposite angles should be supplementary. So if the similarly, this one over here should be supplementary to this one down here. Similarly, you can see my marks. The base angles should be congruent. So the bottom left and the bottom right should be congruent, and the top left and the top right should be congruent. Okay? If you have all these properties, and you have all the packets that we gave you, all the stuff that we did before break, you're going to be doing just fine. Okay, for the test on Wednesday, I would expect that you know 8.1, which is all about the interior and exterior angles. Okay, interior angles being 180 times n minus 2, and the exterior saying that all the exterior angles always sum to 360 degrees. In addition to all these properties that now hopefully you have on one piece of paper, I want you to study those, and if you study those, you'll be just fine. Tomorrow we'll review in preparation for the Chapter 8 test on Wednesday. Hey, have a good night.